What's up, pre-calculus students? We are going to go through the practice multiple choice questions, one unit at a time. Um, you can use these videos to help you. This is the no calculator part. These are the questions where if you had a calculator, it would help you tremendously. So we expect them to be given to you as no calculator questions. And unit one was about rates of change, shape of functions. I think what's really key is to remember like the differences between whether you're told your graph, what's going on with your graph, or what you're told about the rates. So a quick little example that I like to put is like, let's talk about the graph, let's talk about the rates. Your graph could be, say, positive or negative. If your graph is positive, that means your graph is above the x-axis. Then you could talk about your graph increasing. If your graph is increasing, that means overall it's going up. And then you could talk about the concavity. Your graph is concave up. If your graph is concave upwards, it's curving upwards, whether it's decreasing and curving upwards or increasing and curving upwards. Now, this is different from if you were told your rates are positive. If your rates are positive, rates of change being slopes, y's per x, just calculating the change in your y's over your change in your x, you get your y's per x, a unit rate of change. If your rates are positive, your slopes are positive, your graph is increasing. So these two things correspond. And then we talked about what happens if our rates are increasing. If our rates are increasing, our graph actually curves upward. Now that's like concave up, slopes that are like -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Those values are increasing. -5 is less than -3, which is less than -1, which is less than 0, which is less than 1, which is less than 3. These are values that are increasing. A lot of people think that this is decreasing at a decreasing rate, but that's not correct. We see that the graph is concave up, so that means this is decreasing at an increasing rate. Even if you Google this, there will be pictures that will say this is decreasing at a decreasing rate. But no, the slopes are like -5, then -3, then -1. Those values are increasing. Okay? So we're either calculating rates of change or we're talking about the shape of our graph based on rates of change or based on some information. As for the average rate of change, we're just going to find the change in my y's from -2 to 4. That's +6. I could calculate that by doing 4 minus -2. But from -2 to 4, you can see you add 6. Over the course of 3 x's, that's 2 y's per x. Say we have a piecewise function. It's very important to just make sure you're looking at the correct piece based on your inputs. I have 1 and 5. So I really just need to find the y values correctly. I'm going to be using this. So that's 4 minus 15, which is -11. And then I'm going to plug in 1 as well. And that's going to be 1. So my y's decrease by 12. Over the course of 4 x's. We can look at consecutive rates of change over equally spaced input lengths. You can see we go 1 to 2, 2 to 3, 3 to 4, 4 to 5. We can see we are adding 30 per x, then we are adding 10 per x, we're adding 5 per x, adding 1 per x. So those rates of change are decreasing. Thirty, 10, 5, 1. So we got to be concave down because the average rates of change are decreasing. My function's increasing at a decreasing rate. So increasing at a decreasing rate. Increasing concave down. From 4 to 8, this might look crazy, but like you're just going to look at the overall rate of change, how many your y's change over the course of x's. We go from 1 to -3, so my y's went down 4 over the course of 4x's, so that's -1. You could also calculate that by doing -3 minus 1 over 8 minus 4. And it's the same thing here. I go up 1 over the course of 9. Oh, never mind. Sorry. When is the average rate of change the least? The least. So the least would be the smallest positive value or the biggest negative value, right? -5 is less than -1 or 1. So keep that in mind. So we just got to calculate all the rates of change from 0 to 4. I increase 4 over the course of 4. From 0 to 8, I increase 0 over 8. From 5 to 8, I go from 2 to -3. I go down 5 over 3. From 6 to 8. So you got an open circle and a closed circle. You use the point. So 6 to 8, you can see the slope is -1. Or you go down 2 over 2. This would be the least value. It's not the one closest to 0. It's the smallest value, the largest negative value. Okay. We can see equally spaced intervals +4. Make sure you're taking that into account when you're doing the rates of change. So I'm going to go down on average -1/4 of a y per x. Or I'm going down 1/4 of a y per x. This is down 4 over 4, which is down 1 y per x. This is down 3 y's per x. This is down 10 y's per x. And we got to think about this for a second. I'll be right back. Got to open the door. Cool. I'm just going to look at the values. I go down 1, down 4, down 7, down 10. It might be easier to look. Divide all these by 4. What did I mess up? Oh, this is down 7, not down 3. What am I doing here? Down 7. So the rates of change are decreasing. It is not a linear function. The rates of change are not consistent. You can see the second rates of change are consistent. These are the rates of change divided by 4. These are the change in the rates of change. These are consistent. The rates of change are linear. Since the rates of change are linear, the model is quadratic. That's the second rates of change are constant. Okay. Let's again look at the rates of change. Equally spaced intervals, -3, -5, -8, -10. These rates of change are negative. The function is going down. The function is going down, and it's going to be concave down, going to be going down at a decreasing rate. See, the rates of change are decreasing. Yeah, it's not like quadratic, but you can see the rates of change are decreasing. The rates of change are decreasing. The rates of change are negative, and the change in the rates of change are negative. The function's decreasing concave down. It's probably best to just look like the rates of change are negative and decreasing, -2, -3, -4. So the function is decreasing concave down. Gotta get the door again. You could also look at the graph. You could look at the points. As long as you're like somewhat accurate, 6 to 3 to -2 to -10, you can kind of see how it's going to be kind of moved down. All right, it's unit one. 1 unit down.